This is a question about quantum numbers. Let's go through each of them. For principal quantum numbers, there's theoretically no limit. There's, for the elements we know, in ground state configuration, they go up to 8 for the principal number. N, by the way, is how we abbreviate it. As long as it's a counting number, so like numbers 1, 2, 3, 4, 5, and so on. So any counting number would be a valid principal quantum number. I use the word counting number as like a mathematical term. Okay, how about angular numbers? You can have as many angular numbers as is equal to, as long as it doesn't exceed the value equal to the principal quantum number minus 1. So angular numbers, they start at 0 and count up from there. So for example, 0 corresponds to an S sublevel, 1 corresponds to a P sublevel, 2 to a D, 3 to an F, 4 to a G, 5 to an H, ... because theoretically there's no limit to that. You can have as many angular numbers, and as long as it's a valid angular number, so we call it a sublevel, as is equal to the principal number. But if your principal number is 3, then you could theoretically only go up to the first, you can only list out the first 3 angular numbers, which only gives you a value of 2. Oddly enough, it's 1 less. Your angular number can be no more than 1 less than your principal number. And if that's not confusing enough, then we have, by the way, the abbreviation for angular number is a cursive L. Then we have another one, it's called magnetic number, magnetic quantum number, whose abbreviation is an M with a subscript L. These numbers can range in value from the negative angular number to the positive angular number. So if your biggest angular number is, let's say, 3, then your magnetic numbers could range from -3 to 3. And they have to hit whole numbers. You can't just have fractional magnetic numbers. To answer this question, this much information is sufficient, but there is one other number. I just want to mention it briefly. There's something called the spin quantum number, which can only have 2 values, either +1/2 or -1/2, indicating positive spin or negative spin. And that the way that manifests is only a maximum of 2 electrons can exist in any given orbital. You could have no electrons in an orbital. You could have 1 electron, or you could have 2, but those are your only choices. Okay, so with that information, let's go through each of these questions. In part A, n equals 2. Sure, you can have any principal quantum number, as long as it's a counting number, like 1, 2, 3, 4, and so on. Angular number 1. Since the angular number is 1 less than the principal number, that's valid. So that's perfectly fine. Magnetic number, -1/2. Since the magnetic number can range in value from the negative angular number to positive angular number, and if your angular number in this case is a +1, that means your magnetic numbers could very well be a -1. So that's okay. This is an allowed set of quantum numbers. Totally fine, valid. Problem B, n equals 1. Of course, you can have any principal number as long as it's a quantum number. As long as it's a counting number, rather. Angular number 1? No. That is not okay. This is bad, because your angular number can be no more than one whole number less than the principal number. And the reason for that is your angular numbers count, they start counting at 0. Well, if your principal number is 1, then that means the only sublevel that can exist is the one that has an angular number of 0. So that's not okay. Let's analyze the magnetic number just for kicks. Can you have a magnetic number of 0 if your angular number is 1? Yeah, that would be okay, because it falls into the range of negative angular number to positive angular number. So for question B, this is not allowed because the angular number is not valid. That's a problem. Problem C, n equals 8. Sure, you can have any principal number as long as it's a counting number. L equals 7. Is that okay? Yes, this is okay because the angular number is just 1 less than the principal number. Now, what sublevel that would be? Well, geez, what I know of is S, P, D, F, G, H. I don't know what the 6th sublevel is, or I'm sorry, number 6 angular number is, or the letter designation for number 7 angular number, but that doesn't matter. All I know is it falls within the confines of being acceptable. And then lastly, the magnetic number is -6. Does that fall into the value of negative angular number to positive angular number? You bet. This is okay. That's allowed. Problem D. N equals 1. Of course, that's fine. L equals 0. Yes, that's the number you start with. Your angular numbers always have to start with 0, so that's okay. Magnetic number 2. Here's the problem. Your magnetic number has to range in value from negative angular number to positive angular number. If we've established that your angular number is 0, that means the only magnetic number that's possible is also 0. So this is not okay. So I would click the box next to not allowed. The magnetic number is not valid.